Tool height, and before we get into it, I want to first talk about what tool height really means. So in the Z direction, you're going to have two offsets active. You have your work offset and you have your tool height. So in this diagram here, I'm showing tool height as a positive 5 inches. So it's important to know it's positive in this case. And the tool height is the distance from your tool tip, lowest point on your tool, to the spindle nose, which is that cylindrical face at the bottom of the spindle assembly. So in that case, this is 5 inches, positive 5 inches. And then your Z work offset is the distance from the spindle nose to the Z0 on your workpiece. So in this case, we're calling Z0 the top of our workpiece down here. So we have a positive 5 in our tool table. So we're going to call this, we're working with tool 18 here. So the tool length or height, those words are interchangeable. Length and height for tool is 5 inches. And then the Z offset in G54 is negative 11 inches from here down there. So these two numbers are working together to give you the total distance that your tooltip needs to travel to get to Z0 on the workpiece. So again, your absolute value is going to take both these numbers into account. So from home position in Z, you're going to add negative 11 plus 5, and that gives you the distance you need to travel from home position to Z0 on the workpiece. And in this case, just for this example, that's negative 6 inches. So really quick, I'm going to tell you another way that people do this, which is not how I recommend. So some schools teach this. They'll put a 0 right here for your Z work offset, and then they use a negative number for the tool length. So in this case, your work offset would be 0, your tool length would be negative 6. So in that case, you still have two offsets working in tandem, and those offsets still add together to be negative 6. I think there's a couple reasons that is taught. First, it's simpler because you know you always have a 0 here. And second, if you do forget to do your G43 with your H value, if you're manually programming, you're less likely to crash a machine, because if it doesn't do this negative offset, it's just going to start your tool paths up at home position, which is safe. So the downside of doing it that way is you have to touch off every single tool that you're going to use anytime you set up a new workpiece. So it's a total pain as far as that goes. But it is still fairly commonly used. Okay, so back to the way that we are going to do it. This Z value is the distance from home position to Z or 0 on your workpiece, from the spindle nose to 0 on your workpiece. And the tool length is the actual length of the tool in a positive. So this is going to always be negative, this is always going to be positive, the way I'm suggesting to do it. Alright, so the first thing we need to do if we want to be able to touch off a tool, we need a known surface. So I'm going to take a known tool and face off a piece of scratch aluminum. So I have a Z0, a known 0. I'm currently using G54. If your G54 is being used for something else, you can use a different work offset. But as you can see, I'm activating the tool height and turning on the spindle on this tool, which is my face mill. So G43H6 matches the 6 for the tool number. And as you see, my absolute value changed as soon as I activated that. So now I'm using the hand wheel to come down in Z. I'm just going to lightly touch the top of this part. You can see my cutter is off to the side. Since it's not a center cutting tool, I don't really want to be right on the middle of the part. So I touch, I'm going to move in negative X direction to get off. And then I'm just going to come down like 5 or 10 thousandths in Z, so that as I come across in the X direction, I have a fully clean surface that I can face off. So once I'm done with the hand wheel, I always set it back to off position, just in case I bump it, that I could screw something up. So I'm going to go to jog mode. My feed override I'm going to set to 55. If you look at the middle number, that 55 is my jog feed rate. And then I'm going to turn coolant on. My spindle's already running. And then I'm going to jog in the X positive direction. So I hold this button down, and that creates a jog. And I apologize for the bad video quality here, but the tool is jogging across the part. You can see now it has fully faced off the part. So before I move Z in the Z direction, I want to call this Z0. So I'm going to go to my work offsets for G54, type Z0, and then measure, which is a soft key there. So that set my Z to 0 in absolute. My G43H6 is still active, which is important. Now I'm going to do a 0 return and send Z home. So I'm finished with the initial part. I created a known Z0 surface that I can now use to touch off a tool. So I want to make sure my door interlock is set to release so that I can have motion in the machine while the door is open. I'm going to bring Z0 or bring Z down. I normally use two hands to do this. So I came down, I touched the paper. I want to get to the point where I can feel not only some resistance in the paper, but almost like it could rip if I pulled it any harder. Right now my tool height is not active on this tool. And if I go to my work offsets, if you think right now my tool height is not active, that means the spindle nose is effectively my tooltip at this point. So the spindle nose is above my workpiece by the distance, which is equal to my tool height or tool length. So I'm at absolute 4.992 right now with my spindle nose. If I type Z and then this input C button, that transfers the Z value from my relative position over to my tool 18 length. Alternately, you could just type 4.992, which is the absolute value, and hit the input button. And in this case, I already had 4.992, so it did not change that number. But it's important that our absolute value matches our tool length in this case. So now I'm going to send Z home again, 0 return Z. And that's a safe thing to do because Z will never travel in the negative direction with a 0 return. And the last thing I'm going to do is use a tape measure to verify that I did it right. So from the spindle nose to the tooltip, looks like it's just a little, slightly less than 5 inches. which is what we have, 4.992, and I'm happy with that. Coming back to this, as we bring the spindle down towards the workpiece, if we have not activated G43, which is our tool height offset, that means the spindle nose, as far as the machine is concerned, is the tooltip. So as we bring the spindle nose down to roughly here, where the tooltip is touching, the distance from our Z0, which we have touched off, to the spindle nose equals the tool height. So in this case, we were pretty close to 5 inches on our tool. So at that point, our absolute value, which is the position of the spindle nose, equals our tool height. Now, as soon as we activate tool height with a G43, our tooltip shifts from the spindle nose down to the actual tooltip, which is where we want it when we're doing anything related to programming. So hopefully that makes sense for everybody.